So today you are going to learn the chapter Trigonometry of class 10 mathematics. This chapter is actually one of the very important chapters and very difficult also for children. Really seems to find it actually very difficult. You know why difficult it is? Because children fail to go through the basics of this this chapter. You know, the basics of this chapter, trigonometry, is really triangles. So here we are actually going to learn some of the basic aspects of triangle, and then in the coming classes we will get into the chapter. So before getting into the chapter, we need to have actually a basic class, a class which we are actually dealing with triangles. Here I will be talking about the triangles parts, then the type of triangles, then the properties of triangles, then the Pythagoras theorem. These are the things I am actually going to tell you in this chapter. This video class is actually different from the class which you are actually attending in the school and all. You know, while the teacher in the classroom is repeatedly mentioning the same content again and again until and unless the children are actually getting the concepts clear. But in the video classes, the content will be mentioned only once, because people have the facility of actually playing the video again and again and learning it perfectly. So we need to reduce the size of the video also. So we will be telling the concepts once, and then you have to play the video again and again. So you should not get confused with this is actually not the way the teachers are teaching in the classroom. Not like that. It's a video class and the things will be mentioned only once. Okay, listen very carefully. So I'm actually going to define a triangle. See, triangle is actually a closed figure with three line segments joining together. Triangle is a closed one. See, it's a closed figure and these are the three line segments joining together. So we call it as A, B, C. So we call it as triangle ABC. You don't have to worry about this definition of triangles and all. It won't be coming for the examinations and all. This is actually just for the sake of understanding, the better understanding of the chapter. You may record this type of things and all. So triangle is a closed figure with three line segments joining. So okay, then what are actually the parts of the triangle? So we have three parts of the triangle. The first one is sides. We do have three sides: side AB, side BC, side AC. So like that, line segment AB, line segment BC, and line segment AC. These are the three sides of the triangle. You know that. You don't have, I don't have to mention it again and again. Then we know after that sides, you know the other one is? Yes. Yeah. It's angles. These are the three angles of the triangle. So angle A is the angle, angle B is this angle, and angle C is this angle, right? These are actually the way we represent angle with one alphabet. We can actually write the real name of the chapter, of the angle should be mentioned by three alphabets. So this angle A means BAC. If you are actually using three alphabets to mention an angle, then the middle alphabets should actually really mention the angle. So BAC. Otherwise, CAB also correct. But the only condition is the middle letter actually should represent the angle. So angle A means BAC. So I can write BAC also. So if it is B, this is the angle I am actually going to talk about, to write. Then what is actually the name of the angle with three alphabets? It's A, B, C, O, yeah, C, B, A. So angle ABC I am writing. Then C, A, C, B, O, B, C, A. I am writing A, C, B. So these are the three angles, and these are the three sides. And we do have one more thing in this triangle. You know what is it? It is the vertex B, the vertex C, the vertex A. What is actually vertex? Vertex means the place where the two line segments join. So we do have three vertex. So the plural of the vertex is the vertices. So we do have three vertices, A, B, and C. So you say vertex A, like that. You can write vertex A, vertex B, and vertex C. So we have actually three things: sides, angles, and vertices. So these are actually the part of a triangle. Triangle ABC, if you look into this triangle seriously, then we have three parts: the sides, the angles, and the vertices. The name of the triangle is triangle ABC. Right, the second section of the basic. So we learned about the triangles and the parts of triangle. This much only we learned. Now we have to learn these two things in the next video, this video. So type of triangles, types of triangles. How many types of triangles we are actually going to deal with. So the name or the type of the triangles is actually really classified by looking at the angles and by looking at the sides. So if you draw a triangle here, see this is a triangle, triangle A, B, C. Now you can classify the triangle, you can name the triangles by looking at the angle and by looking at the sides. Now we are actually going to learn about by looking at the angles. The first one, the angles. Okay, so what are actually these angles? What type of a triangles? Before that, we have to learn about three things: acute angle, obtuse angle, and right angle. You might have learned about these things, right? I'm actually not going to teach you all these things. You know that. The angles between 0 and 90, between 0 and 90 is an acute angle. Between 90 and 180 is actually an obtuse angle. And if the measurement is 90 degree, it is actually a right angle. You know that, right? So this is an acute angle because the measurement is between 0 and 90. This is a right angle. This is a right angle. And this one is an obtuse angle. So because the measurement is more than 90. So this is 90, this is less than 90, this is more than 90. So this is acute, this is right, and this is obtuse. You know that. If it is 190, we call it as straight angle. You know that. And if it is 0, then we call it as a 0 angle. So 0 and 190, even though the numbers are here, it is actually not coming in this picture. Even though the 90 is mentioned 2 times over here, it doesn't go with any of these two. Between 0 and 90 means 90 is not there. Between 90 and 190 means 90 is not there. So 90 means right angle. So you know that. So I'm forgetting about that. Now, if all the three angles of a triangle, here, all the three angles of a triangle are acute, then it is called an acute angled triangle or an acute triangle. If all the three angles are acute, if all the three, it is actually very important because next time I am actually going to teach about a right triangle. Then I'm actually going to say if one angle is right, 90 degree, then we call it as a right angled triangle or a right triangle. So here, if one angle is 90, it is called a right triangle triangle. If all the angles are acute, we call it as an acute. Say acute means less than 0 and 90, between 0 and 90. Between 0 and 90, between 0 and 90. Here we don't worry about the other two. It's of course it should be acute. That is actually not going to mention here. And here this one, if one angle is obtuse, here also when you say the definition, one is coming. Here all the angles are acute, we call it as an acute angle triangle. If one angle is 90, we call it as a right angle triangle. If one angle is obtuse, we call it as an obtuse angled triangle, or to say obtuse triangle. So, if by looking at the angles, whether it is acute or obtuse or right, because by looking at the measurement, If this is actually a line, then if the second line is here, the angle is 0. If the second line is here, it is 90. If the second line is here, it is 180. If the second line is, this is 90. Between the 0 and 90, somewhere here, all these angles are acute angles. If this is 90, right? Then this is 190. Between all these angles are 190. See, for example, this one is an obtuse angle. See, this one, this line. This line means it's an acute angle. Clear, right? And this is the right one. So if all the angles are acute, then we call it as an acute angle triangle. If one angle is 90, then we call it as a right angle triangle. And if one angle is obtuse, we call it as an obtuse angle triangle. Now we are actually going to learn about the types of triangles by looking at the sides. Last time we learned about the type of triangles by looking at the angles, and we call it as acute angle triangle, obtuse angle triangle, and right triangle. And now we are actually going to learn about the type of triangles by looking at the sides. So I'm actually drawing a triangle here, triangle A, B, C. Call it as triangle A, B, C. Right, good. Now let's look at the sides of the triangle. So this is 4 centimeter, this is 5 centimeter, and this is 6 centimeter. Let it be. If all the three sides of the triangle are different, we are actually looking at the sides. If all the three sides of the triangles are different, then we call it as a scalene triangle. A scalene triangle. And now another triangle. A, B, C. For this purpose, I am actually drawing only the acute triangles only. Okay, acute angle triangle or acute triangles. Okay, here this is 4, and this is 5. If two sides are equal, then we call it as an isosceles triangle. Isosceles triangle. And now we have another type of triangle by looking at the sides A, B, C. If this is 4, and this is also 4, then we call it as equilateral triangle. Equilateral triangle. Now, if all the three sides are different, we call it as scalene triangle. If any two sides are equal, we call it as an isosceles triangle. If all the three sides are equal, then we call it as an equilateral triangle. A scalene triangle, an isosceles triangle, and equilateral triangle. These are actually the classification of triangles by looking at the sides. So totally we do have 6 names, 3 by looking at the angles and 3 by looking at the sides. By looking at the angles, we do have 3 names like acute triangle, obtuse triangle, right triangle. And then by looking at the angle sides, we have scalene triangle, isosceles triangle, and equilateral triangle. Now, properties of triangle. You do have 2 very important properties of triangle. You know that. This is actually just for the sake of saying it. You know that. The first one is very clear, everyone knows that. The second one may not be that clear, so I will explain the second one more, and the first one is easy. So the first one is by considering the, by naming the triangles, we used by looking at the angles and by looking at the sides. Here also in properties, by looking at the angles we do have one, and by looking at the sides we do have one. What is actually the property of the angles of a triangle? The properties of the angles of a triangle. There is a special property, an amazing property, an unbelievable property. You know that one? The sum of the angles of these triangles, if these are 60, 60, and 60, then the sum of the angles of the 3 angles of the triangle is 180 always. Always. If you take any triangle, see for example, this is 100. This is an obtuse angle triangle. This is 100, and if this is 40, then this will be 40 because 100 plus 40 plus 40, 100 plus 40 plus 40 is going to be 180. This is always right. You can actually try with a right triangle. This is 90 degree we know. Then this is actually 30. This is maybe 60. Anyway, 90 plus 30 plus 60 is going to be 190. So the sum of the three sides of a triangle is always 180. That is the first property. Here we are here. The sum of the three angles of a triangle is 190. Now, if you consider the properties of the triangle with the help of the side, if you look at the side, this is the triangle. Then, as we mentioned last time, 4, 5, 6. These are the three sides of the triangle. Take it anything. You know, very important property by looking at the sides. The sum of the any two sides of the triangle is greater than the third one. Sum of any two sides of the triangle is greater than the third side. Sum of any two sides of a triangle is greater than the third side. See, I will take, this is the first side, this is the second side, this is the third side, we call it as, okay? The first one and second one. 4 plus 6 is greater than 5. Correct, no? 4 plus 6 is 10, 10 greater than 5. Then the second and third we will take it. 6 plus 5 is greater than, then the other side, if you consider these two, the other side is 4. So 6 plus 5 is 11. 11 is greater than 4. Then you consider these two. 4 plus. Now take the first one and third side. First one and third side, 4 plus 5. And first one and third side means, and the third one, next one is 6. So 4 plus 5 is greater than 6. So 4 plus 5 is 10. 10 greater than 6. So sum of any two sides of a triangle is greater than the third side. You take the, suppose 1, 2 and 3 as the three sides of a triangle. Suppose you see. So this is first one and this is second side and this is third side. So the first one and the second one is greater than the third side. 1 plus 2 is 3. 3 greater than 3. It's a wrong statement. So what is the conclusion? So 1, 2 and 3 are not the sides of a triangle. With 1, 2 and 3 we cannot construct a triangle. So sum of any two sides should be greater than the third side. If coming in the other way around, you cannot construct a triangle. So this is a very important property. Last time we studied Pythagoras theorem. 100 is one side, 40 is at the side and 30 is at the side. Construct a triangle. Sorry, because the sum of this one is 170, which is not possible. So by looking at the side and angle, there are actually some certain criteria, some important rules that the sum of the three angles of a triangle should be 190 degree and the sum of any two sides should be greater than the third side. Sum of any two sides should be greater than the third side. I repeat, sum of any two sides of the triangle is greater than the third side. This is actually the two properties of the triangle. Now, we learned this much. Now we are actually here in the Pythagoras. Anyway, these many things won't come at all in the examination. These are actually for the better understanding of the chapter or the concept of the triangle. So these are actually not going to be asked in the examination. But whereas Pythagoras theorem is required for you people to solve the problems in this chapter. Unless and until you know the Pythagoras theorem, you won't be able to do the problems, any problems of this chapter. So now you have to listen very carefully. This is very important. Pythagoras theorem. If you really want to learn the Pythagoras theorem, then think about the different types of triangles you learn. You learned acute triangle, you learned obtuse angle triangle, and right triangle, and scalene triangle, and isosceles triangle, and equilateral triangle. Many triangles you learned. Now we are actually going to take only the right triangle. We are going to deal with a right triangle. This Pythagoras theorem can be explained only in a right triangle. So Pythagoras theorem is something which is explained in right triangle. What is a right triangle now? So this is the very important thing of this chapter. So to tell you this right triangle, about this right triangle, I was actually telling all these things. So right triangle means a triangle with one angle 90 degree. I told you, when I was actually defining this one, what is a right triangle? How I define the right triangle? So if one angle of a triangle is 90 degree, it's called a right triangle. Now we have to go and learn more and more about right triangles in detail. So that is actually what is recorded in the Pythagoras theorem. Now look here. So if this is 90 degree, if this is the angle which is 90 degree, then the side opposite to this one is having some specialities. That is actually going to call as hypotenuse. Hypotenuse. Hypotenuse is actually the side opposite to the right triangle. Side opposite to the right triangle. And that is actually going to be the longest side. This is very important. Every time you have to think about, whenever you see hypotenuse, this is going to be the longest side. Okay, this one is called a side, just a side. If you want to call, it has actually you call a base, and this is called altitude. But that is actually not important, because when you are actually doing something of this kind, when you put the triangle the other way around, this side and altitude may change. If you are actually going to see, if I am actually going to turn, if I am actually going to change the board, then see what is actually going to happen. This is actually different. This is not altitude. This is the altitude, and this is the base. So that is actually not every time possible to name these two sides with base and altitude. It may change, but this is actually cannot be changed at any cost. This is the longest side of a triangle. If anyway, whichever way you keep the triangle, up or down or whatever it may be, the side opposite to this one is called hypotenuse. So the hypotenuse is the most important side of a right triangle, the side opposite to the 90 degree. Okay, now once again, if this is a triangle, then call it as ABC, the triangle ABC, right triangle ABC, right triangle at A. Then normally what we do is, the side opposite to this one, we call it as small letter A. This is actually say like 7 centimeter, 8 centimeter. No, the side opposite to C, normally call it as C, and the side opposite to B is normally called it as B. So these are actually the three small letters we are actually using it. A, the side opposite to A, the same small letters we are actually using it. So you know what is the Pythagoras theorem says? The Pythagoras theorem says that A square is equal to B square plus C square. A square is equal to B square plus C square. Sum of the squares of the two sides of the triangle is equal to the square of the hypotenuse. I repeat, sum of the squares of the two sides of a triangle. I told you, these are base and altitude. I said it's better to say side. This is also side. Side one, side. That's all. So the sum of the squares of the sides of a two triangle is equal to the square of the hypotenuse. So A square is equal to B square plus C square. See, A square, the bigger side is hypotenuse. That is the square of this one is equal to square of this one plus square of this one. I will actually take some more examples. It will be clear. So a right triangle. So let's say this is 3 and this is 4 and this is 5. This is actually a right triangle. Square of this one is equal to squares of these two. So you call it as A, B, C, and this is A, and this is B, and this is opposite to C. This is 5 centimeter I am saying, this is 3 centimeter I am saying, this is 4 centimeter I am saying. See, what I am saying is square of this one. Here everywhere we have to find square. What is a square? Square of a number. Square of a number 7. What is the square of a number? Square of a number means square when into 7, 49. The square of a number is 49. Children by mistake say 7, they multiply with 2 and write 40. No, this is wrong. What is the square of 8? 8 into 8, 64. So the square of 8 is 64. What is the square of 9? 9, 9, 81. The square of 9 is 81. So that is what is actually I am saying. Square of the hypotenuse is equal to square of this one plus square of this one. So square, 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 square. Let's see this one. What is the square of this number? 5. What is that one? 5 into 5. That is 25. What is the square of 3? 3 into 3. That is 9. What is the square of 4? 4 into 4. What is that one? Is 16. See, this one is equal to this one plus this one. Correct? 25 is equal to 9 plus 16. 16 plus 9 is how much? 25. So, square of the hypotenuse, this is square of the hypotenuse. How you got the square of the hypotenuse? How you got that one? This 25 is means 5 into 5. This 9 means 3 into 3. This 14 means 4 into 4. This is the way you got that 14, that 16. This is the way you got 9. This is the way you got. So, 25. So, how you got this 25? 5 into 5. How you got 9? 3 into 3. How you got the 16? 4 into 4. So, square of the hypotenuse is equal to sum of the squares of the other two sides. Sum of the squares, already squares we found out, and the sum of the squares is 9 plus 16 is 25. 16 plus 9 is 25. So, this is called the Pythagoras theorem. Now, here, if I will be asking you how to find this 9 from 25 and 16, so this is a smaller number. So, you have 25 and 16. So, what you will do? 25 square minus 4 square. So, I will come to that one little more detailing. If you have 3 numbers, if you want to find the largest number, if you want to find the largest one, how will you find the largest one? 3 plus 4. So that means if you want to find this one, it is plus. Because this is the largest one. This is the hypotenuse I told you. Okay. If you want to find this one of the small numbers, how will you find one of the small numbers? You will add? No, this is small number. No. So you have a bigger number and another small number. So you have the bigger minus smaller. See, 4 is equal to 7 minus 3. How will you find the another small number? This again is smaller number. You have 2 other numbers. One is bigger, another is smaller. So the bigger minus smaller. So here also like that. Here also it is A, it is B, it is C. So if you want to find A square, this one, A square is equal to, if you want to find this one, the sum of this one we have to find B square plus C square. So if you want to find C square, this is a smaller one. Smaller one means we cannot add it. You have to subtract. Subtract means which one is the bigger one? This is the bigger one. Bigger one minus this one. So A square minus B square. So another B square you want to find. This one. Is a bigger one or a smaller one? It's a smaller one because the bigger one is hypotenuse. So this is a smaller one. So you have a bigger one and a smaller one again. So what you will do? You will add? No, you will subtract. So A square minus C square. So you should learn this one. How to find the hypotenuse? How to find the other sides? If you want to find the hypotenuse, which is opposite to 90 degree, then add the squares of these two. If you want to find this one, it's a smaller one. Then this one minus this one, right? A minus. If you want to find this one, this is a smaller one. Then again, the bigger one is here, a smaller one is here. So A square minus C square. Because children are actually making mistake in this side. Because sometimes or every time, most of the time, they will plus it, they will minus it without knowing. So if you have, see the same example. If you have 2 smaller one and a bigger one, how will you find the bigger one? By adding the 2. How will you find the smaller one? You will subtract the smaller one from the bigger one. Like that. So this is a right triangle at A. So this is the hypotenuse. We know this is the bigger one. So you want to find another smaller one. So you call it as actually AB. So AB is the line you want to find. So AB square is equal to, see, this is a smaller side. This is a smaller side. So the sign in between is going to be plus or minus. So smaller one can be found by subtracting from this one from this one, right? So AB square is equal to BC square minus AC square. Correct, no? AB square is a smaller one. So the bigger one is always the hypotenuse. So BC square. So the bigger one you wrote first, and minus AC square, the other smaller side. So what is this one? AB square is equal to BC square is how much? BC square is 13 square minus AC square is 12 square. So 13 times 13, you multiply, you will get 169 minus 144. So if you subtract 169 minus 144, you will get 25. So 25. So AB square is 25. So AB is equal to square root of 25, which is equal to 5. You will learn this one earlier. So I don't have to teach you this one, right? This is the way you have to write it. I want you to write like this while doing the exercise, while doing the worksheets. Okay. Another one. Let's take another example. Triangle ABC. ABC. Let's take the example 6 and 5. 6 and 5. And how much is this one? So you want to find the bigger one. So you want to find the bigger one means BC square. Everywhere you have to put square. So Pythagoras theorem says that the square of the hypotenuse is equal to sum of the squares of the other two sides. That means square is applicable to everywhere. Square is applicable to all the three sides. So BC square is equal to, this is a bigger one. So the sign between these two one is going to be plus or minus. The bigger one can be obtained by adding this other smaller, right? So AC square plus AB square, right? So AC square is how much? AC square is how much? 6 square plus AB square is how much? 5 square. So 6 square is 6 6 are 36 plus 5 5s are 25. Why this plus you understood, no? These are two smaller sides. You have to add it and get the bigger side. Okay. So 36 1 plus 2 6. So 61. So BC is equal to square root of 61. We cannot find furthermore. So the answer is square root of 61. So this is very important. Pythagoras theorem you have to really learn by doing it. More and more questions in the worksheets, and you have to submit it at the earliest. Thank you. Next class we will go to the chapter Trigonometry, and that video will be coming to you soon. Hi.